Kepler's center of gravity addresses mass as matter. Relative equilibrium does not conflict with this view when seen as the disposition of force of an equivalent relative mass. Relative equilibrium is considered proportional between paralleled entities and could, if to measure some form of Einstein's matter, be defined as E/Z2 for an equivalent representation of relative mass with respect to matter as m. For the Sun and Earth, relative equilibrium is seen as a relationship of an inner and outer relativity of their relative masses. They have a shared spatial time that is derived from their covariance of relative forces. m2/d1 equals m1/d2 equals 0. Relative mass is seen as the equivalent potential energy of a body if viewed as a manifold or a uniform relative force like a sphere. This is where acceleration is measured at a rate represented as relative equilibrium with respect to some time t, such as the speed of light. Relative gravity or Rg is to account for a relative mass as manifold E/t. Based on the inverse rule, a property, relative equilibrium, Re, should be equated to a manifold's state of change. Additionally, Re can also represent the rate of acceleration of an object E/t. In application, Re is to be derived from relative gravity Rg, such as between, for example, the Sun and the Earth. This is where acceleration is measured at a rate represented as Re, or m1/d2 equals m2/d1. Demonstrated in relative equilibrium, similar to Newton's constant g with respect to Earth, gravity affects all objects the same way. But, one must go beyond Newton if to explain this similar behavior for our solar system. This is part of Re's scope. Here, disposition of force is considered proportional between paralleled entities, such as like the Sun and Earth. But also includes other heavenly bodies too. In retrospect, it is somewhat intuitive that two large magnets can respond mutually at a greater distance between them than if one is smaller, and that if the Earth were at Saturn's distance from the Sun, would the same field strength that it currently exhibits with respect to the Sun be able to keep it in orbit, or even be able to maintain the conditions known for Earth, such as atmosphere, or Newton's constant g. Re is seen as a relationship of an inner and outer relativity of relative masses, or their covariance in terms of relative forces. For example, Saturn is assumed here to have a field strength based on its size. This field strength is thought here to allow it to orbit at its own distance from the Sun, and the Earth proportionally for its ideal distances for its size. The obvious question is, can Newton's constant g apply to Saturn, or for relating the gravity between it and Earth? Mechanically, Re represents the point of balance between the relative forces of entities in Rg. It is to be generally conveyed as a relational field strength. That is, where matter A, distance relative to that matter A, but not equals to matter B, distance relative to that matter B. Re plays a major role in relative gravity. Re can further serve as a basis to conceptually fabricate a knit behind spatial fabrics touched on earlier. This has to do with the distance that is relative between entities, such as black holes, and their parts. Even the Milky Way on a clear night can be easily imagined to be like spatial fabrics of stars. The stars can also represent a lattice or knit of other spatial fabrics which make them up. This latitude in reasoning can extend gravity as a practical application. That is, in addition to solar systems, and galaxies, and in addition to their merging. The reasoning for spatial fabrics is seen somewhat different than Einstein's view. Einstein's fabrics are interpreted here as in being warped by heavenly bodies. This is regarded here, but with theory that looks more at constituent parts. For Rg, in a manner to evolution, as currents, spatial fabrics most likely warp others where relative mass aka Rm could be expressed by them. This is described later as uniform relative force or URF. Similar to a piled sheet, a primeval example is seen as the relation of heat and cold, and when and where they coalesce in Re. At a minimum, black body radiation is produced. For spatial fabrics, such as heat and cold, this is generalized for representing our universe in some form of plasma thought to consist of currents of amplitudes and voltages. As particle is implicit to galaxy, seen as fabrics X, Y and Z, all are considered to consist of unique manifolds of E/T. They are thought to be expressions of relative mass when combined in a realm of context represented as a new instance of relative mass that occupies spatial time, similar to a particle as dimension X, Y, Z. In this fabric of fabrics, Re can be considered analogous to mutual space. This is where a measure in the state of any two or more bodies as relative masses result in net zero in force. In other words, normalized through distance, body A, body B, equals zero. This net zero in force is thought of as a dynamic of proportionality where based on the inverse rule effect mentioned earlier. For Re, in offering a mathematical constant, given two bodies of different size, seen, is that the smaller has an equal normalized force with respect to the larger. This is thought to be consistent with the behavior of gravity as in affecting all things as being the same and where Newton's constant G can be applied to Earth. Given two bodies with field strengths A and B, where they share proximity, they will have a net force of zero. The relative force between A and B is seen to remain equal relative to the distance between them as a spatial time even on the subatomic level. The point of balance or quiescence in Re is represented as where there is net zero force. For an atom this could even be construed as the perception of a neutron where appearing as the net result of the resonance of an electron state and proton state of a particle, or from their combination. Essential to Re is the notion of relative distance. Noted, the actual distance the Sun and Saturn share is a relative distance with respect to a mutual force between them. This distance is considered equivalent to the one between the Sun and the Earth. Believed, this is in order for both Saturn and Earth to meet the same basic requirements in order to orbit the Sun. In other words, given their masses they are proportionally located away from the Sun.
Relative gravity, or RG, aims to incorporate a relative mass as manifold ET. According to the inverse rule, a property known as relative equilibrium, Re, should be equated to a manifold state of change. Mechanically, relative equilibrium, Re, represents the point of balance between the relative forces of entities in RG. It is generally conceived as a relational field strength, where matter A's distance relative to matter A is not equal to matter B's distance relative to matter B. Relative equilibrium plays a major role in understanding the dynamic equilibrium of celestial bodies and their gravitational interactions. Equilibrium refers to a state where opposing forces or influences are balanced, resulting in a stable or unchanging system. Now, when we talk about relative equilibrium, we're considering this concept in relation to the masses of different objects or bodies. Imagine you have two objects, say the Sun and the Earth. Relative equilibrium in this context means that the forces acting between them are balanced, resulting in a net force of zero. This balance is proportional to the relative masses of the objects and the distance between them. So even though the Sun and the Earth exert gravitational forces on each other, they remain in relative equilibrium because their masses and distances are such that the forces cancel each other out. Now let's move on to Kepler Center of Gravity. Johannes Kepler was a famous astronomer known for his laws of planetary motion. It's essentially the average position of the mass of the objects involved. Relative equilibrium, when applied to Kepler's center of gravity, is consistent with the concept of mass as matter. It doesn't conflict with this notion, but rather offers a complementary perspective by considering the disposition of force of an equivalent relative mass. This equilibrium is proportional between paralleled entities and can be represented as Eg2 squared for an equivalent representation of relative mass with respect to matter as m. In the case of celestial bodies like the Sun and Earth, relative equilibrium illustrates the relationship between their relative masses, which share a spatial time derived from their covariance of relative forces. This relationship is expressed as m2 over d1 to m1 by d2 equals 0. Relative mass is viewed as the equivalent potential energy of a body. Whether it's perceived as a manifold or a uniform relative force, Similar to a sphere, this concept allows us to measure acceleration at a rate represented by relative equilibrium with respect to some time t, such as the speed of light. The analogy of a piled sheet illustrates the dynamic interplay between heat and cold in the universe, much like the overlapping layers of a fabric. When heat and cold converge, they create intricate patterns and interactions, shaping the environment in real time. This analogy highlights the complexity and interconnectedness of natural phenomena, reflecting the principles of relative gravity in action. Relative gravity, RG, can serve as a conceptual framework for understanding the intricate interplay of spatial fabrics in the cosmos. These fabrics, akin to a lattice or knit, comprise celestial bodies such as black holes and stars, including the Milky Way galaxy itself. Viewing these celestial objects as components of spatial fabrics allows for a nuanced understanding of gravitational interactions. Unlike Einstein's interpretation, which focuses on the warping of space-time by massive bodies, RG considers the constituent parts of these bodies. In this view, spatial fabrics warp each other based on the relative mass, Rm, of their constituent parts. This perspective extends beyond individual solar systems and galaxies, encompassing their interactions and mergers on a cosmic scale.